Hello, hello, hello again. This will be your lab, pre-lab lecture video for the fractional distillation lab, which you'll be doing today. Um, so this will be a pretty quick lab video to watch because again, those lab flow videos are pretty self-explanatory, but I just wanted to explain a couple things. So today you'll be doing a fractional distillation, and part of that is, let me just draw what it looks like real quick. Right, you have like a round bottom flask, okay? And I've never been good at drawing round bottom flasks, so I'm going to try that one more time. There we go. That's a little bit better, right? And then the round bottom flask is connected to this thing called a fractional column. Fractionating column, right? And then the fractionating column has this little joint in there, like this, and a thing up here to hold a thermometer. Okay. And then this joint here connects to the distilling column. That. And it's kind of double layered. So is the fractionating column. Okay. And that comes out to another little joint down here. Okay. And then over here you can have just like a beaker or a graduated cylinder to collect things that come off. Right? You can collect things that come off. Drip, 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 drip. Okay. This round bottom flask is usually heated by a thing called a mantle, which is basically a hot plate, except this hot plate is covered in fabric and it actually engulfs the bottom of the round bottom flask. So the reason why we use a round bottom flask is because it actually distributes the heat better in the reaction. And what happens is that you'll have a solution, a mixture, right, of two, maybe three, who knows, liquid solutions, compounds mixed together, and they'll have two different boiling points. Okay, and what a fractional distillation can do is that it can separate those solutions or those compounds based on their boiling point. Okay, so a very common application where you hear about distillation is alcohol, right? When you're distilling vodka, for example, which back in the day when I was an organic chemistry student like you are today. I say back in the day, but it really wasn't that long ago. So anyway, I used to actually, take, some yeast, like bread yeast, right, and do things like ferment, you do the regular thing, which is like ferment sugar water, right, and to make like vodka, but you can flavor it by putting other things in it too, like not sugar, potatoes, right, to make vodka. But I used to throw things in there like bacon and all kinds of other stuff. Well, after you ferment it for a little while, you get this like mixture of like nastiness in there, but it smells like beer, and and it makes you feel kind of sick because it looks nasty, but it smells like beer. And then you would I would take that mixture there, and I would pour it all into a distillation apparatus like this one, right? That whole mash into there, and then I would turn on the distillation apparatus, right? And what it is that inside this fractionating column here, right, there's these little beads, or you could use wire or chains, right? And they make what we call theoretical plates, where the solvents or the liquids in there can evaporate and then condense and then evaporate and condense all the way up the column. And the more surface area you have inside that fractional column, right, the better you get separation. And you know as well as I do, when you're separating out water from alcohol, you want to get the most pure as possible, right? And so after you separate it out, I think I'm sorry, it's a little late at night right now, so I can't remember what the exact boiling point of alcohol is, like ethanol. It's either 78 or 74 degrees Celsius. if you're watching this and you're on YouTube, post a comment below and remind me. I'm pretty sure it's 74 or 78, one of those two. But that's a very big, that's kind of a different boiling point than water is, right? And so you can see how if you boil it, the thing that has the lower boiling point will evaporate first, and then the thing that has the higher boiling point will evaporate later. And so in this case, the ethanol will evaporate first. So we turn on the heat, and it starts to bubble, right? Usually there's like boiling chips in there, so you can control the bubbling, and the alcohol vapor starts to float up the column, right? And it condenses, and on the chain or the beads or whatever you put in there, as to increase the surface area inside there, right? It keeps on condensing and evaporating and condensing until it makes it all the way up here to where this joint is up here, okay? And that's where you have the thermometer, and it's sticking down in there too, right? The thermometer actually is inside that joint via a thermometer adapter that has a little rubber gasket on it, so you can put the thermometer in there and make sure that no vapor comes out, right? And you need the thermometer there because the vapor of the alcohol will be the temperature of its boiling point, so that's alcohol coming off of there. So whether it's 74 or 78 degrees, that's the temperature you'll see on the thermometer as it's passing up into this joint up here, right? So my first, I know this, you're doing this virtually, but one day you might want to distill some alcohol. But you need to be very careful though when you install the thermometer in the thermometer adapter, because I had this friend, well, he's not really a friend, he's an acquaintance. And when we were in class, in organic lab, and he was installing his thermometer into his thermometer adapter. I don't know what he was doing, but he wasn't really using a thermometer adapter. He was using a stopper, a rubber stopper with a hole inside, which we have those too, but they're not for thermometers, right? And he was like forcing that thing down, the thermometer down like this into the thermometer into the rubber stopper, trying to get it through the hole, thinking that was the thermometer adapter. Well, it wasn't, and it broke when he did it, right? And I specifically recall my friend Danny, my acquaintance Danny, raising his hand, right? Because I was in a different fume hood and he was in a different fume hood. He was raising his hand, and I can't remember who our TA was at the time, but raising his hand, he's like, I think I hurt myself, and the hand that he rose was the one that had the thermometer sticking in it. Like, it was literally a thermometer, broken glass thermometer sticking through his hand, right? And it was still in his hand when he was raising his hand. So, of course, they had to clean up all the blood, and they took him to the hospital, and they came back the next day, and his hand was completely wrapped, So, word of the wise to you, right? Don't confuse a rubber stopper with a thermometer adapter. And when you're inserting, even in the thermometer adapter, which can be kind of tough sometimes, make sure you're not like trying to jab it down like this, but you're actually, you'll see what I'm talking about when you watch the lab flow videos. You need to hold the thermometer, very close to the rubber stopper, or not the rubber stopper, so don't do that. Hold it very close to the thermometer adapter and push it in very slowly like this, so that it doesn't break on you and get stuck in your hand, and and then it's a complete catastrophe. Luckily, it was an alcohol thermometer, not a mercury thermometer. Otherwise, it would be a complete mess. Mercury is toxic, so don't even get me started on that. Oh, I forgot to tell another story. So, in the organic lab, we always use things like heating mantles or hot plates or baths to heat things, right? And you should absolutely never use a Bunsen burner, because the vast majority of organic solvents are highly flammable, right? And they are also like low volatility too. High volatility. They have low boiling points. And so the vapors will kind of like, if you pour it into a flask, they'll kind of overflow from the flask and kind of float on the outside of the flask. And so that's why you're not supposed to use like an open flame, like a Bunsen burner flame. You're supposed to use, safer heating sources like a heating mantle or a hot oil bath or something like that. Well, I think I mentioned this in one of the previous lectures or pre-lab videos, where we had this method called the white method, and so it really has nothing to do with the with this whole thing here, uh, but this same guy who we coined this method after, he was doing a distillation. Actually, it was a reflux, right? A reflux is very similar to a distillation, except you don't have any distillation stuff at all. It's just a fractionating column on there. And what you do with that is that you make it so that you can heat up a reaction pot, right? And the vapors condense, but they come straight back down again and back into the pot, so it doesn't dry out and stuff. And then you can have a reflux going on. So he was doing a reflux, and he was, it was over an open Bunsen burner flame, and it was done, right? And so but he didn't take off he didn't turn off the flame, and he pulled out the fractional column, but so the solvent he was using was ether, and ether's, you can smell ether from like a mile away. And so ether vapors were just overflowing from the flask, and the flask like literally catches on fire on his hand, like in his hand. He's holding the flask, right? And it's on fire, and we were all like, what do you want us to do about this? Because it's on fire. And as cool as a cucumber, he takes it over, and puts the flask into a wooden box and closes the wooden box. So it extinguishes the flame, of course, but that's just a story to reiterate the fact that you shouldn't use an open flame with any kind of organic reactions, right? Anyway, so you can still do this distillation and virtually. And so what happens is the ethanol will go up there and evaporate, and condense until it reaches all the way up here. And then it will start to go up into the condensing column, which is the one that's going across over here, right? And the special thing about the condensing column is that it has like a little hose right here, right? And this hose attaches to a faucet. With a sink. Okay. It kind of looks like a faucet, right? And so water will flow. You'll turn on the sink, and the water will flow up the hose into the condensing column. And remember, I said it was dual layered. And so it will go into the layer that's outside, like the layer between the two glass layers, and flow and cover the entire condensing column with cold water. And then it will come out the other side here into the sink. Okay. And it'll come out to the sink. So I told you guys about this one time when I flooded an entire lab and the third floor because this hose that I had up here popped off and the water's going everywhere. Not a good day. I had to evacuate the building, had to dry things. It was a bad day. Anyway, so make sure those things are very secure. Okay. And since there's cold water going around this column, it condenses the alcohol, the ethanol, into little droplets, and the droplets flow down and it collects down here in the graduated cylinder or the beaker or whatever you're using to collect your alcohol. Okay. So you need to keep an eye on this thermometer because if it's between 74 and 78 degrees, right, while you're doing the distillation, then you're still pulling off alcohol. But if that temperature rises, getting close to like 100 degrees, then you've gotten to the water, so you need to stop the distillation because then you'll start mixing the things over here on this side. And that's basically how a fractional distillation works. One of the things to take note of is, though, that water has this thing called an azeotrope with ethanol, right? And so have you ever noticed, like, when you go buy out, like, liquor at the store, like maybe at Specs or something like that, we have a liquor depot, like, right, like on the corner of the street near my house here, so you can just walk to the liquor depot if you wanted to. Dang, I wish I had a bottle of Everclear here I could show you. But this azeotrope, what it means is that you can never get water 100% out of the ethanol, and so you won't ever have pure like drinking ethanol that's 100% ethanol, also known as 200 proof. It's always 95% or 190 proof, right? And so Specifically then what that means then is the azeotrope of water and ethanol when you're doing distillation is 95%, right? Because you can get up to 95% pure ethanol. The rest of it will be water because of that. That's this thing called the azeotrope. So I know people have seen before, like especially in chemical labs, ethanol that's like 100%. But the thing about that is that ethanol has been denatured, right, with other organic solvents, so that it will be able to, be distilled from water up to 100%. And you definitely don't want to drink that stuff. So be careful. But when you're distilling things, and the original mash had corn in it, right? You used corn to do the fermentation. That's literally Everclear. Um, Things like whiskey and rum and all that, they're all distilled the same way too. But the reason why they're brown is because they're put in barrels and they're aged for a while. Potatoes is used for vodka, and so I was making some as a kid, making some alcohol. Good times. Anyway, it's a pretty easy lab. Just go through and read the PDF document. Of course, you'll be separating. I think I don't remember now. Let me actually take a look. Let's see here. There it is. So you'll be fractioning. You'll be doing a. Yes, here we go. You will be doing a. Yes, you will be separating ethyl acetate and butyl acetate virtually. So have fun with that. I'm really sad that you don't get to do this kind of stuff in the actual lab because it's kind of fun, barring any disasters, catastrophes like thermometers in hands and flasks just bursting into flames and stuff. So or water hoses popping off. Okay. Anyway, good luck in lab today, and also don't forget that you have an exam tomorrow, and good luck on the exam too. And I'll be around to answer questions today. If you have questions about the exam, not about the exam specifically, but questions before the exam. But once the exam starts, I cannot answer any more questions. All right. Good luck, and I'll see you. Oh, I won't see you again until there's an exam solutions video, or even maybe the next lecture on Monday. All right. Bye.